In this video, we're going to be looking at multiplying and dividing radicals. So it's very similar to what we did in the previous video. We're just going to be building on it with multiplication and division. So again, we're going to make sure we remember our perfect squares from before. So we have 1 squared is 1, 2 squared, 4, and so forth. And I'll go up to 10, but obviously you can go further than 10. Okay, so for this one, we're going to be using what's called the product rule, right? So what the product rule says is that if you're multiplying two radicals, like let's say A and B, you can put them under the same radical, right? So it's just kind of very similar to the property we did in the last video where we were breaking it up. We can put it together. So when we're multiplying, we can either simplify first or we can multiply and then simplify. Lots of ways to do the same exact problem. I'm going to put them in one term first and then simplify. But you might find, like, for example, in the first question, you might want to reduce 12 first, right? So many ways to do the same problem. Basically, what happens is what's on the outside will multiply each other, and what's on the inside is going to multiply each other. So when we look at this, -4 times -3, that's going to give us a positive 12 on the outside. And on the inside, I'm going to do 12 times 5, which is 60, right? So I simplified this to now be one term. And it's very similar now what we did in the last video. So the square root of 60, our largest perfect square, even though 60 is 5 times 12, our largest perfect square is actually going to be 4 times 15. Square root of 4 is 2. And then whatever's outside the radical is going to multiply each other. So that 12 and that 2 are going to be multiplied. And our answer is going to be 24 radical 15. And that would be our final answer. For number 2, it's essentially the same thing. If I don't see a number in front, I actually assume there's a little 1 here. You don't have to write that, but just keep that in mind. So it's like you have a 4 and a 1, and a 4 and a 10 that are getting multiplied. So 4 times 1 is 4. Inside is 4 times 10, which is 40. The largest perfect square that goes into 40 is 4. So 4 and 10. And then we would get 8 root 10. This is an example of one, though. If you saw in the beginning, you might see, hey, that's actually a perfect square right away. I might not have to do that. And that actually would have saved you some time. So we would have had, like, the square root of 4 is 4, or is 2. So we can make that a 2 right away if we really wanted to. And you see you got the same answer and actually end up being a little faster, right? So lots of ways to do the same problem. The second one's probably faster, but if you do forget, you would still end up with the same answer. For the next two examples, this is where we're going to be using the distributive property, like we saw for variables. We're just distributing a radical. So for this first one, I'm going to distribute to both terms. And now we're just going to use our multiplication property. So in this first one, I have radical 3 times radical 2. In the second one, I have radical 3 times -3 radical 3. We can then simplify. So they're both inside a radical, so it's like they go inside the same radical. So I'm going to do 3 times 2, which is 6. This is a negative times a negative, so that's a positive. And then, and actually, I realize this should be, sorry, that should be a 3. outside. And this is like a little 1 in front. So -1 times -3 is positive, so that's a positive 3. And radical 3 times radical 3 is radical 9. And then after we distribute, we're going to see, well, can we simplify? So the square root of 6 we can't do anything with. The square root of 9, though, ends up being, it's a perfect square. It ends up being 3. So we have radical 6 plus 3 times 3, or radical 6 plus 9. We can't go any further because there aren't any like terms, so we would stop there. For the next one, same idea. I'm going to distribute radical 5. So I would have radical 5 times radical 10. This would be a positive. And then radical 5 times 4. Keep in mind the 4 is not inside of a radical. So if they're both inside, I could put them in the same one. So this is root 50. The 4 is actually out here outside, so that would actually go with like an imaginary 1. So this would be 4 radical 5. So we just move it to the front. And then I'd have to simplify the square root of 50. So the square root of 50, that would be 25 times 2, or 5 radical 2, plus 4 root 5. They both don't have the same number under the radical, so they're not really considered like terms. So that would be your final answer, 5 root 2 plus 4 root 5. And then finally, for the last type you'll see, you're going to see a lot more dividing when you actually, start school in fall, maybe with rationalizing. We're going to see more of just like what happens when we simplify. So a few things to keep in mind. When we divide, we use something called the quotient property. So what that means is if I take two radicals I'm dividing, I could put them under the same radical and vice versa. So really we can kind of use a version of that if it applies. So in the first one, I have the square root of 6 over the square root of 25. 6 over 25, if I made that as a fraction, doesn't reduce or do anything nice. I do have a 25, though that's a perfect square. So on the bottom, we would have 5. On the top, we'd have root 6. And this would be our final answer. For the second one, same thing. Root 15, nothing happens to it, but root 4 becomes a 2. That one's kind of nice. For the last two, we might have to do something a little different. If we, don't see a perfect square, one thing we might want to look at is if I put them under the same radical, do they reduce, right? So if I was, all right. So if I was to put, there we go. About that. So if I was to put these under the same radical, root 8 over root 2, if I make this like as 8 over 2, would that reduce to anything? And it actually would. So we would still have the 2 on the bottom. If I put these under the same radical, it would become radical 4 on the top. And so the square root of 4 is 2. On the bottom, we would get 2. So our answer would be 1. And so if we can put, if two numbers under the radical can reduce, we would go ahead and just do that. Same thing with 10 and 8. If I reduce 10 and 8, this becomes root 5 over 4. Or 3, the radical 5 on top and the radical 4 on the bottom. And then we can simplify. So on the top, nothing really happens. On the bottom, the square root of 4 is 2. And our answer would be 3 root 5 over 10.